All right, folks, we're going to start talking about reinforced concrete. This introduction, this first week, whatever. But we're really talking about two materials. We're talking about concrete, and then we're talking about steel reinforcement. So this is a little bit different than a lot of the stuff that you've talked about before. You've talked about steel. I mean, you talked about steel and strength of materials. You talked about steel and structural steel. Really haven't talked about concrete too terribly much. Maybe you talked a little bit about it early on in your couple of your courses or whatnot, but we're going to talk about concrete as a material. So a lot of the stuff that we do, starting off talks about concrete, talks about what concrete's made up from, components of concrete, talks about some of the properties, unusual properties that concrete has that other things don't have. One of the things that I think you could say about concrete that might be a little different is that concrete is one material that really comes to the project site in one state, and you're interested in concrete as it achieves a different state. So it comes to the project site plastic or wet. It gets poured into forms, but we're really interested in afterwards, like when the building or the facility is occupied, because that concrete has to have a certain strength, durability, and other characteristics. So, I mean, it's a different type of material. A lot of your materials, hey, they get shipped to the site, they are what they are, we erect them, we put them up, and that's it. Concrete, we're interested in getting it in, building with it, then we're also very much interested that it achieves certain properties later on. Okay? So in that aspect, it's a different type of material altogether. So, so think about concrete as in two states: plastic state or a wet state, and then a hardened state or a state that we'd use it in. So, when I talk about the components of concrete, different books, different resources will do different things. I usually like to talk about concrete as having 5 separate components. And so we talk about the components or the ingredients in concrete sort of one at a time, and sort of get to try to understand the components, and that'll help us understand concrete. So the first thing is when we talk about components, the first component is going to be cement. All right? Now, with cement, here's one thing I always tell students. You coming out of this class are going to be different than they talk about the 99% and the 1%. You've heard that. All the politicians say 99%, 1%. You are going to be the 1%. All right? Because 99% of the people in the world don't know the difference between concrete and cement. You watch the local news, you read the local paper, when they talk about a construction site, construction progress, hey, it's a beautiful day at Cincinnati, and look at these workers are pouring, and what do they say? 99% of the time. They're pouring cement. Okay? Or they'll even show a concrete truck, and they'll say, look at this cement truck. They're pouring what type of sidewalk are they pouring? A cement sidewalk. 99% of the people will use cement as being equivalent to concrete. It's not. Because cement, when we talk about cement, it's Portland cement. Portland cement is what? It's a powder. Okay? If I was pouring cement for a sidewalk, it'd be a pretty dusty place, wouldn't it? All right? So that's the big difference. You're going to be the 1%. You're actually going to get the terminology correct. All right? You're going to use concrete the way that it's meant to be used, when you use the term. Cement's just a component of concrete. All right? It's an important component of concrete because it really provides concrete a lot of the qualities that we think we need in concrete. All right? The first thing that you should know about Portland cement is that it's manufactured. There's a fairly long process that the manufacturing process of Portland cement is fairly long. You take raw ingredients, clays, limestones, things like that. You grind them up, and then you burn them. There's a couple different processes they can use. They can use what they call a wet process. They can use what they call a dry process. But the fact of the matter is you take these raw ingredients, which literally come out of the ground, you grind them up, in certain proportions, you burn them. And the stuff that's left over after the burning process is sort of a round pellet type residue that they call clinker. This residue, the stuff that's left over after the burning process, is then ground up very finely, goes through they call it a ball grinder or a ball mill, and it basically has all these steel balls that are rolling around that, grind this clinker up. They add a little bit of gypsum to it, okay, probably less than 5%. And the result of this is Portland cement. Okay? So again, basic raw ingredients, literally we dig out of the ground. Probably a lot of times nowadays they use the wet process, so they take this stuff and they build actually a soup out of it, and then they send the soup through a kiln process, and the soup is burned, and what's left over is this clinker. Okay? They can add other stuff to it. I mean, if there's admixtures that they'd like Aaron Training admixtures, they can add that to it. But the long and short of it is it's a relatively energy intensive. Some people will say a dirty type process, just because it really uses a lot of energy. Okay, but that's Portland cement. Portland cement was discovered back in the early 1800s. It's I think in the United States, our first cement manufacturing company was actually the Clopay Company in the late 1800s, 1870, 1880. That's basically about the time that concrete was being used, as in the modern times, as we know it, as a building material, like the late 1800s. Okay, so you won't see concrete buildings, too many of them, dating back, like prior to like 1890, 1880. I mean, they made stuff back then. It's just it's no longer around. Probably UC in Cincinnati has some of the oldest concrete type buildings. They have buildings up on main campus that are 1910, 1908, 1910, 1915, stuff like that literally are concrete frame buildings, and that are still in existence. So, again, probably most of the oldest buildings you'll see in Cincinnati, probably if they're concrete or concrete structures, probably it'd be about the turn of the 20th century, 19 something, okay? Because the concrete hasn't been used all that often. But Portland cement, again, manufactured since the early 1800s, but again, concrete as a building material probably came sort of to the forefront in the late 1800s. So, manufactured. What else do you need to know about it? You already told me it's sort of powdery, okay, very fine powder. Typically a gray powder, although we can make white cements. If you're going to, try to pigment your concrete, make it colored and whatnot, it's better to use white cement just because the colors will be more vibrant. Still, with white cement, is just cut out the raw materials, try to minimize the iron oxides and the stuff that gives us the darker colors. Okay? So, but anyway, you should know that it's expensive. Relatively speaking, it's expensive. Relative to the other components, cement's going to be an expensive sort of proposition. Right now, I think you can go out and buy a bag of cement. You probably pay about 10 or 11 bucks for a bag of cement. And you might say, well, that's less than a 12-pack. But you got to remember how many bags of cement you're using in a cubic yard, and all of a sudden that starts to get expensive. We talk, and already I've said a traditional bag of cement is a 94-pound bag. The old people would call this a sack of cement. All right? You still have people talk about bags when they talk about mix design, because they might say, hey, we're using a 6-bag mix. In a cubic yard of that concrete, it will have 6 times 94 pounds of cement in it. So it's relatively expensive. People will talk about bags. There are different types of cement. People talk about types 1 through type 5. Okay? The fact of the matter is, 1 is a normal cement. So, I would imagine you'll get 90% of the time you'll get a type 1 cement, because that's just a normal everyday cement. They do make a type 1/type 2. Type 2 is a sulfate resisting cement. And you can actually, the difference between types is the difference between certain chemical compounds that are in the cement. So they make the cement act a little bit differently if you blend it a little bit differently. And so, but type 1 is the normal. You might see a type, if you get a bag, it might say type 1/type 2. That's because you can blend them to actually meet both categories. The type 3 is an high early strength cement. It's blended finer, it's ground finer. And if you grind the cement up to be a finer powder, the chemical reaction takes place quicker. Type 4 and type 5, type 4 you'll never see. It was for dams and whatnot. And type 5 is a high sulfate resisting cement, but we'd handle that a little bit differently. So.